audible?
Yeah, it is audible.
Right. So what I will do, I will start on the camera. Am I visible?
Yes, you are.
Okay. So let me start sharing the screen. After that, I will start recording. Just let me know if the screen is visible with the along with the screen share.
Yes, it's visible.
Very
Yes.
good. So okay, let me then start off with the
So,
recording.
did anyone find any difficulties in our session one? If you have
So
any,
shall I make the recording on?
yeah. But if anyone
Okay.
faced any issues in your session one course modules or quiz or practicing during the lab, please feel free to ask the question.
Actually,
Okay.
I missed the last session. Then can I get the recording of it?
It is already published in our website.
Okay, okay. Thank you.
So you would be you would go to a website, then you go to the week, first week. On the very top, you will see the recording on the list of activities. On the first list, you will find the recording. So let's start without any further delay. Good morning, good evening, good afternoon to many people from joining from various parts of the world from different time zones. Okay, uh, so thank you for joining this session. We are going to have our view, our knowledge sharing with AWS Cloud. But before that, we would like to do a little bit of that thing which was left over from the previous session, isn't it? Like we were stuck at pushing our changes to the GitHub repository. Do you remember? If you had followed the first week with the DevOps introduction, you could recall that there is a site hiccup, and then we will like because I just forgot the password. So let me go and do the push. So you know, I will go to my you are familiar with this. This is the Git Bash, which is sort of a Linux thing where we were doing all this. So can you see the screen? I am I, I'm there on my Git folder, which is the DevOps one, and I'm in the master branch. I had already committed few of the files onto my local repository. Okay, so let's say you were just to have a recap of what we did is what we are going to do is this is let's say we are going for this. This is our sorry. Mm, so this is oh sorry, this is too sensitive. The local repository, the local repo. This is our laptop for Windows or for Mac. Okay. From there, from this local repository, we have made some changes, isn't it? We had made several changes over here. Like uh, then we have added the changes, and we have committed the changes. Now this is the stage we are ready for push. Push where? Push to our GitHub. So let's say this is our remote machine on somewhere on the internet called the GitHub. This is the server. Okay, this is where we are going to push. Let's see that. I will just what I will do is before I go here, I must know that there is, if I say git remote -v, you have this particular remote repository where we are going to push it, where we are going to push the changes. Now, what we do is also to know what is the state of our status. So git status, you will see that nothing is there to be further committed to the master branch of the local repository. Is that fine? Right? Do you agree? And if I say git log and I would like to have a one-liner of the logs, then you will see that there is this is the origin master, which is a few commits behind the local. Local is this one, the green one is the local. The master is few commits behind. So it is an ideal situation where we can put in our changes from here to the remote. Before that, let me go over there. You see, this is my repository, remote repository, and we do not have anything, okay, or it's empty, other than the README file on the main branch. So let us see if we can push, and if you can see, the config is already there. The config is there. So I am having this account. This is the email ID, and of course there is a password which will not be displayed over here. And the remote origin is this one, the one where I'm going to put in. So git push origin, and in the origin, which branch? It didn't have the master branch. So let's pick this one up from the local repository and put that into the master, into the GitHub. Let's do it. So similarly, it is asking for the account name. So I know, let me do it slowly. Devashish Jeff, and I like to copy this one. Let's see if it works this time. The password has been removed. So let me bring that. I think this was one. Or let me go into this. What I'll do, I will go into this one and quickly set up my password. Go to the settings. I will go to the developer settings. This is the entire settings of my account. Okay, I will like to create one personal access token very quickly, and I will go to the tokens classic and let me generate a new token. Okay, and I will go for the generating a new token in the classic version. So let me say my token for Devops, any name that you can give. I would like to give a 30 days expiration, that is fine. And I will say the select scopes. I would like to write and delete and admin. I have these scopes, that is, these are the privileges with this particular password. I'm sort of giving everything without any filtration. This is just to get that push done. Okay, so I'm giving basically everything. Yeah, so what I did did all the scopes of this privilege, and I will generate a token. Now I will quickly copy this. This is the token which was generated, and I will put it over here such that I do not forget it, because this will be generated only one time. Okay, and once I do that, I can go back to my repository. This one, isn't it? That is my repository. Okay, that is the main branch. Okay, and now I will go back to my this thing. I will make a further attempt with the git push. Let's see. Git push origin master. So Debashish GIF is my account, and just now I have copied. Let's see whether it can help me. Oh yes, yes. So this time, because of my issue that I have resolved, I have generated a new, personal access token. It is called personal access token with this, or it is called PAT. It is called PAT, and with the help of which I am being able to push my changes, because that it needs an authentication. So that without a personal access token, you will not be authenticated to push anything, because you cannot push in whatever you like, because it's somebody else's account. You have to know the account personal access token. With this, I now verify what happened over here. Okay, the master, it has given a master had a recent pushes 1 second back. 1 second back, it has push. So what I do, I will see that there is a master branch. It was originally with the main branch, then it will have a master branch. And what we do is, can you see all these files which were there on my local system? If I go there, I will see LL, or you can say ls-l. You see, these are the files into my current folder, Devops 1, which we have created. Remember, as if these are the Java files or Python files or whatever the files. It could be image files, it could be video files, it could be whatever files you may think. It can be an HTML file, it can be a CSS file. Any changes that you have done on your local repository, you have pushed it to your master. Or maybe if you wanted to push it to your created branch, you can do that. So isn't it nice that your files have now been reposited onto a remote repository? This is somewhere on the internet with some account. You can verify my third file. My third file is having, this is one line. We have just to understand this topic. Okay, so if you go there and say vi my third file, you will see the same thing. This is my third file, and is exactly the same. Clear? So I think whatever little we have discussed over on the previous weekend, that is with the introduction to DevOps and with some hands-on with Git, I think we can switch over to our new topic today for this weekend, which is AWS Cloud. Is that fine? Any questions? Can you see the screen?
Yes, sir.
Yes, sir.
Very good. And so we are going to this fantastic topic called AWS Cloud, Amazon Cloud or Web Services. Let me open the slide screen. Is it visible?
Yes, sir.
Okay,
Yes, sir.
great. Yeah, great. I will just open that, that pen writer if there is some need somewhere, and I will remove this. Okay, yeah. Or I can minimize this. Yeah. So we are going to understand a bit of, we are going to discuss about Amazon Web Services, which is a very, very important understanding if we want to go further into our DevOps knowledge, because DevOps is entirely, I mean, most of the tools, all of the tools, and whenever you work in an organization, they will be working on a platform which is maybe in on premises, doesn't matter, but it will have Linux, okay, as the server software or the operating system, and mostly they will be hosting their servers and their platform over onto a cloud. And the most popular cloud among all the clouds available in the market today is, of course, Amazon Web Services or Amazon Cloud, which we in short is called AWS. I think all of you have definitely have gone through that. There is the most famous AWS Cloud. Let us go it a bit of details inside it. You may be ready with your questions, but it will be better if I can take your questions only after we had in the designated question and answer session. Okay, is that fine? But if there is immediately some questions that is very much haunting your, I mean, you are restless with that particular question, please shout. No issues. Now, what is cloud computing? I hope the screen is very clear to you. Okay. Now, in a very simple word, these are the definitions that we have picked up from Amazon itself. So Amazon is defining cloud is the on-demand delivery of IT resources. Now, you know, most of the earlier clients or the customers were having their own data centers, their on-premise infrastructure, isn't it? So they would be investing a lot of money. What you say, the capex, the capex and the opex. Opex is for the operational, whatever investments they do for the day-to-day operations, and the capex is the one-time investment, and they can have several investments, but they are capex, which is the capital investment, capital expenditure for acquiring a big server, a big infrastructure for the servers, the network, the storage, as the so many things that there is needed for an IT infrastructure. But nowadays, with the advent of cloud and with these services coming up, a cloud, like you manage services, and the most popular cloud is providing these companies, these big companies or medium-sized companies, the option to go to the cloud to get all the IT resource services from the cloud. So you do not need to invest on your own infrastructure. Let us get it hired from the cloud platform itself, because cloud has everything ready. Whatever you need, whatever you ask for, it is there for you. So and the most important thing is, it is in the capex. What happens in the capex? You invest on a fixed amount, and that fixed amount will be growing day by day, or rather every year you have to give an annual maintenance fees for those engineers and for those companies who had provided with that infrastructure. So it's a huge amount of investment, not only on the first year of the capital investment, but it will be recurring every year. Whereas, while you have given everything onto AWS, you pay as you go pricing. That is the most lucrative part of it. That means you say, I will pay only for what I use. Isn't it fantastic concept? So you use servers, you use a large memory, a hard disk, a big network. All these things are fine. You use it. Nobody is asking you, and you get it on the fly. But what happens is you only pay for what you use. You should not pay. See, when you make a capital investment over your infrastructure, what happens is whether you use or not, you may be using only 20% of your entire capacity. But what you do is you are using it. I mean, you have already paid for it. Whether you use or not, you had already invested. Whereas here, it is like elastic. It is very elastic. You can stretch it, you can relax it. So there is an expansion and there is a compression. So as your need goes up, your usage goes up. As your need comes down, your usage comes down. So the question is whether even when you are not using, are you paying? You are paying when you are doing it on premises or if you have your own data centers, but not when you have given it to over cloud. Okay. So this is a boon in disguise. So instead of buying, owning and maintaining a physical data center and servers, you can access technology services such as computing power, storage, databases, as and when you need on a need basis from a cloud provider like Amazon Web Services. Is the definition more or less clear? Suppose people who are just hearing the going into the technology for the first time. So there is somebody on the cloud sitting somewhere behind the scene providing you all the services with whatever you demand, that is on-demand services. Okay, the services could be for your IT infrastructure, your network, your storage, your computing, whatever you need, it is provided there, even for the application support. Now, everything is there for you and you use it and pay as you go. And there are various pricing slabs, you can select out of it. Whichever suits you, whichever is more pocket saving for you, you go for it. The cloud does not differentiate on the basis of how much and how long it will provide the service based on the pay package that you opt for. No. It is very democratic in that respect. It will not suspend your services because you have gone for a lower package. No. The services, the quality of the services are not compromised. The availability of the services are always there. Anyway, now who is using cloud computing? That is the next question, isn't it? Now, organizations of every type, size. So whether it's a big organization, big five, or it is a medium-sized or a small-sized, a new entrepreneurship organization, a new, say a new setup. So any type, any size, and from any industry can be the user of cloud for a wide variety of use cases. Such that some companies would like to have only the cloud services for the data backup. Data is a big headache for any company to maintain, to have the integrity, to securely store it without the data leakage and all those stuff, information leakage, because information is a very sensitive part of any computing. So maybe a company is needing the cloud services only for the data backup, or maybe they want a disaster recovery, or they want only the email services provided over the cloud. They might need the virtual machines, instances, the desktops, software development and testing, big data analytics, customer facing web applications. Now, there are so many kinds of use cases. For example, healthcare companies are using the cloud to develop more personalized treatment for patients. Okay. So you are at home, you cannot move into a hospital. But will that services be only restricted to once you visit a hospital physically and you meet the doctor physically? Uh, Only then the service will be provided? No. Cloud says you be at your home. We will make every healthcare services available to you at your home, at your doorstep. So financial services companies are using the cloud to power real-time fraud detection and prevention. So because they are financial services company and they have lots of responsibilities of providing a good service to the customer without the fear of fraud and hacking or whatever you say. And there can be video game makers. They are also using. There can be lots of use cases. Let's move ahead. Now, you can see there are the benefits of cloud computing. Can you see the screen? There are the four big benefits, the most important benefits. One is the agility. The agility. Agility means the speed that you want for your delivery, deployment. The cloud, you see, you are as if you are making a sprint. The cloud gives you easy access to broad range of technologies so that you can innovate faster and build nearly anything that you can imagine. Okay? There is no end. You can quickly spin up resources as you need them from infrastructure services. Like earlier days, if you are maybe you are very new to IT industry, but since we are very experienced, we have seen those time when you wanted a server for the development team where the development should start for a project, and the IT infrastructure team will deliver that hardware resource along with the installation of your operating system, along with maybe the database that you want, so let's say Oracle. So this installation of Oracle as well as your operating system on top of a freshly provisioned hardware, which will take not less than 20 to 25 days. Earlier we had experience. And the more bigger the server, the more bigger the infrastructure, the more the time taken for that. But here I can assure you, within not even it will take half an hour that you can deliver your server along with the installation of operating system. If that operating system can be a big operating system like Linux, and on top of it you will have Oracle or Java, whatever you want. It will not take you more than 20 to 30 minutes. That is a guarantee. So it is not only getting a provision some hardware or network infrastructure, it is also the same agility is applied when you deploy your technological services or your applications over the net to your client or to the market. Just in time delivery, JIT from the Japanese technology, that is the Japanese have invented this JIT, just in time delivery. When the customer needs it, be there in the market. If the customer needs it now and you deliver the product, say after a week, there is no value, because in the meantime somebody else has already delivered that feature or that particular product. So you must be always ready to be delivered as and when it is asked. And for that, you need some technology, some support, and the cloud will give you that agility support. Elasticity. Elasticity is another very, very important term. Okay. So what do you mean by elasticity? Can anyone please find out why we say elasticity? What is elasticity? You have learned physics. Okay. Elasticity is the capacity to go beyond a particular limit, but and then you can release it, so it will come back to the normal resilience point. You can stretch a thing up to the point where it cannot break. and then when you release it will come to where you're normal. So it is the same thing with the cloud computing. You don't have to over provision resources. See, in a capex, you had got an estimate that it will need some terabytes of storage, some huge network infrastructure, some huge big machine, big server. And for that, you do it one time and you invest a lot of money. But here with the cloud, you do not go overboard with the investment. You just need to use the resources which are just needed. That's all. Optimum use of resources. When your need grows, it will elastically provide you that additional whatever the resources that you need to sustain that need. But whenever that need does not happen, or it will automatically downsize the resources requirement. So this upsizing and downsizing happens automatically, and that is provided fantastically over the cloud, and that is called elasticity. Whenever you learn AWS, most of the features of AWS will be with elastic, some feature with a prefix called elastic. We are going to come to that. So you can scale these resources upscale or downscale to instantly grow and shrink the capacity as your business needs change. Clear? Now, cost savings. This is one of the most important part, and why the big organizations are moving into it, because the cost cutting, the cost savings are one of the priorities of any organization. Okay. The cloud allows you to trade fixed expenses such as data centers and physical servers for variable expenses. I do not need to maintain a data center and a physical servers. What happens when there is a flood? You never know. And in Bombay, there can be a big data center in Mumbai of India. There can be a big data, but it happened once that with the flood in Mumbai, the data center, all the data, all the servers and everything got a huge impact. It took days to recover the data, the lost data, or to replicate the data from this data center to the other data center. So this is quite a hazard. You have spent millions and millions of dollars over this data center, and once natural calamity with one failure of your normal expectation, everything gets wiped out. So why don't you put all the investments over the cloud? And it could be a very affordable expense, variable expense, and you only pay for the IT as you consume it. You consume it, whatever you have provisioned. You have not consumed the entire 100%. If you have consumed only 20% of it, just pay for 20%. Plus, the variable expenses are much lower than what you would pay to do it yourself because of the economics of scale. The economies of scale is provided by the cloud provider, that is Amazon, AWS. You do not need to manage the economies of scale. It's a big term. The companies are very, very worried about this. They are all concerned about this economies of scale. And if you can manage this, only your revenues will grow. If you cannot manage this prudently, you are going to be getting on the losses side, on the other side. Deploy globally in minutes. That is what we have already discussed. With the cloud, you can expand to new geographic regions and deploy globally in minutes. That means you do not need to be, the world is your global village. You sit in Kolkata or Mumbai or Hyderabad, wherever, Chennai, okay? And you can directly work over a server, over the cloud in US or in Japan. So there is no boundary. Geographically, there is no boundary. So AWS has divided into regions and sub-regions, availability zones. It's a very fantastic way of dealing with, as a global company, you need to have your footprint all over the world without any delay. For example, AWS has infrastructure all over the world. Yes. So you can deploy your application in multiple physical locations with just a few clicks. That is a big advantage. Okay. Putting applications in closer proximity to end users reduces latency and improves their experience. So if you are catering to Indian users, and if you can get your applications more closer to India, like let's say in Mumbai, where AWS has a AWS region, okay? So the latency will reduce. It is over the naked eyes and you will not understand the difference. But yes, technologically, you can be much more faster. Your network response will be much better if you are in the closer proximity of your client. Now this is, you see the Amazon Web Services. This is a very nice picture, if you can think of. You start from the physical layer. That is how AWS is providing the global infrastructure. It has divided the entire world or entire globe into several regions, and each region will be divided into availability zones through the subnets. This is where the VPC, virtual private cloud, is there, and that virtual private cloud is again divided into subnets for the better management of the resources. So you do not you have divided your region. Let's say this is in Mumbai, or this is in Ohio of US. Okay, in Ohio, again, there will be several data centers or subnetworking zones, or called availability zones. So it is like better administration. Why did we divide our country into several states? What is the answer? Why a big state or a big country like India is divided into 28 states and several union territories? Can you tell me? It is because of better governance, better administration. Okay. So similarly, if you have to manage the data quite nicely and distribute it quite evenly, so you divide the big region into availability zones, and these are the edge locations. Anyway, so when we learn cloud, we learn the foundation services of AWS. This is the base. You must learn this before you go to the further part. What are these? The foundation services. We are also going to learn this is the Amazon EC2 compute services. The computational part of it, that is you are provisioning a server. You are creating a server, okay? And then you are also doing some auto scaling. Auto scaling means you are scaling up, scaling down according to the resources, the requirement. So this is the computing part. So you can say that I can provision a big server, I can provision a medium-sized server, I can provision a small server for my need. Okay, so this part comes under, so EC2, you can see Elastic Cloud Computing. This E stands for elastic. So you are creating an instance which is elastic, which can scale up and down. Compute, cloud computing, C2, there are two C's. So that is when you create your service. This is a service. EC2 is a service provided by Amazon. So with the help of EC2 service, you can provision your network, you can use your network, you can use your security group, you can use your key pair to create, and of course your operating system. You will be able to provision your instance, the hardware, the server, you can say. And again, in the storage services, you have several storage services. We have listed few of them. And out of this, Amazon S3 is the most popular and most commonly used, very popular service provided by AWS, which is called Simple Storage Service S3. There are 3 S's. Amazon will always go for some short names. So Simple Storage Service S3. Amazon, this is a very popular service. Then there is another popular service called EBS, Elastic. Again, the Elastic comes, block storage, Elastic block storage. Then there is the storage gateway. There is, like we have discussed, that if a company only wants some storage services from the cloud, then they can go for AWS storage gateway. They might not need this service or this database service or networking service or content distribution service. So these are all services. They want only maybe the storage gateway. They can go for it. So that is what you do not need to go for Amazon for all the, if you want to need only this particular service, you pay for it. Though Amazon is going to give you everything, but you are using this only, so you pay only for this service. That's all. Otherwise, earlier days, the concept was if you had to go for an application or for some software, you have to pay for the entire price, for that entire enterprise price. But here, you just pay for whatever you use, whichever service that you use. Even for database, you will have Amazon RDS. So for a relational database management system or RDBMS or RDS, relational database services provided by Amazon over the cloud. So that means these are all managed services. You see, you have to have a little bit of knowledge on the SQLs of the relational database. Otherwise, you have your design, but the entire services will be provided by Amazon. The security part, the availability, making it run for 24/7 for all the 30 days and all the 365 days. This availability, this securing your data, the integrity of the data, everything will be managed by, you do not need to worry about the health of the database. That managed service will be provided. Like if your company is using NoSQL database, like Mongo database, MongoDB, I think you have heard. MongoDB is not a relational database. It is a NoSQL database. If you want to have that same thing over the network, over the cloud, you can go for Amazon service for DynamoDB. This Elastic Cache is also a database for your Elastic Cache. It is only for your fast search. Why do we create database? It is something which you can query very fast in a very organized manner. Similarly, here, if you have some unorganized data, okay, you can use Elastic Cache to search through the organized data. That means through millions and millions of messages, you want to pick up some structured data out of it and query it. Then there is the networking. So Amazon will provide you the networking services like the VPC, Virtual Private Cloud. Amazon is going to give you the Elastic Load Balancing. Again, Elastic. That means you can balance the load of your traffic, which is requesting your services, the application services. You can distribute that load using an Elastic Load Balancer in between. And that Elastic Load Balancer is a service provided by Amazon. Amazon Route 53 and Amazon Direct Connect, these are all networking services. If you are not an application developer, you might not be interested with these services provided by Amazon. Like the Amazon will provide you the Amazon Cloud front. So you can, it's a content distribution. The technology for making your content distribution, it's a cakewalk with the managed services like Amazon CloudFront. You have you can manage your messaging, the application, because messaging is a very important part of any application development. But you can have Amazon SNS, Amazon SQS, and Amazon SES managing your services for your application. Then there is Amazon Search, the cloud search for quick queries and quick searching over the cloud, your application cloud. This is the distributed computing with the help of Lambda, Lambda computing. Then these are the libraries, SDKs, software development toolkits, Java, Python. All this support for all these libraries are provided with application platform services. Then we come to this part is only if you are absolutely an application developer. But for a DevOps engineer, you might very well understand, you need to understand this part and this part. If you are an operations guy, you are definitely going to understand the Amazon CloudWatch. Okay? Whatever you do over the GUI, that is the graphical user interface, is with the Amazon Management Console. Amazon will provide you a graphical interface through which you can manage, you can implement these services, all these services. Okay? You can initiate these services. And also, you have a fantastic thing with the control. Like, you should not allow all the users of your of a cloud should not be having all the privileges. So you should differentiate between Tom, Harry, and whoever. They should not, based on their role, you must create the privileges and accesses to them. Because see, cloud resources are not meant to be accessed all over across all the functions. They need to be, you have to maintain the sanctity of the access. So you should not give an authentication to anyone to fiddle with or to, to do anything with any of the resources, because those resources, every time there will be a billing. If you wrongly use, or if your usage is not correct and up to the expectation of your company, then your company may end up paying extra bill. And see, everything is audited, so you will not be able to hide yourself if you are. So why don't you do in the very beginning that you provide the specific roles and access to the specific users, and that is done through the identity and access management. It is called IAM, a very important feature or service provided by Amazon. Deployment and automation. We will have one slide for AWS Elastic, again Elastic Beanstalk. How nicely you can deploy your application. Okay, without understanding, without a concern of what is the infrastructure, what is the environment that you need. Everything will be provided by this Beanstalk service of AWS. Now you have, you also have a cloud formation. Cloud formation is another thing that you can deploy your, like you have done this EC2, or you have created your S3, or you have created your Amazon RDS. That is through this Amazon Management Console, you can do that. But you can also do it with a script. You can code your infrastructure, and you can run your infrastructure without getting any help from the AWS Management Console. You can create a script that is automatically, you are doing some automation, provisioning automation. You can create your EC2 instance. You can create your S3 bucket. Okay, you can create your Amazon VPC, you can create your networking elements, you can create your subnets. Now, all these things can be done over cloud formation. This is one very important service of cloud. Next week, we are going to learn Terraform. Now, Terraform is also going to create resources on AWS, but from outside, not using the Amazon Management Console. The concept is similar to cloud formation, but cloud formation is a bit costly service provided by Amazon because it is automation. So therefore, we can use Terraform. It depends on your customer whether they will go for cloud formation, AWS cloud formation service, or they want to go through Terraform. Terraform is much more versatile than cloud formation, of course. We will learn that. And Amazon CloudWatch, as we have said, that for the operations guy, they need to keep on monitoring 24/7 on the product which has been deployed over the production. Okay, so CloudWatch is one of the Amazon services. Like if you say Nagios is not an Amazon service, but it is going to give you the similar functionality of Amazon CloudWatch. So why, if you have gone for AWS, so you may decide, your company may decide that we don't want to go for Nagios. We will better use a managed service like Amazon CloudWatch. Is that clear? For monitoring, and this operation guy will use the Amazon CloudWatch managed service for monitoring the health of the production system. Now, cloud computing models, you can go through this. It is the infrastructure as a service. There is a cloud computing model, types of cloud computing that we do. Okay, infrastructure as a service. I have a very nice diagram, then you will understand. The infrastructure as a service, sometimes abbreviated as IaaS. You might be hearing these terms quite a lot nowadays. You say, I'm using IaaS. You have to know about all these things. Otherwise, it will be very difficult to, first of all, to get a job, to maintain a job, and also, even if you are a manager, okay, you need to be aware of these terms, because otherwise you will not be able to contribute anything over a meeting or with your project team. You should understand this. IaaS, infrastructure as a service. Then there is PaaS, platform as a service. And there is the ultimate, the SaaS, SaaS, software as a service. So naturally, you know that infrastructure, you have something to do with this if you go for infrastructure as a service, as a cloud computing model. You have to do a little bit less work than infrastructure as a service if you go for platform as a service. And you have to do nothing basically. Everything will be managed by the provider of that service. It's called software as a service. We will have a diagram. Infrastructure as a service, sometimes abbreviated as IaaS, contains the basic building blocks and cloud IT, and typically provide access to networking features, computers, and data storage space. So everything is like virtual, but you have to provision them. Okay, so that is called infrastructure as a service. You are doing, you are coding the infrastructure. You can say you are writing some scripts to create your infrastructure, but still you have to do something. Platform as a service. Platform as a service remove the need for organizations to manage the underlying infrastructure. See, if you had created your infrastructure, it is you who is responsible for maintaining them. Whether it is the servers that you have provisioned, or the network, or the storage, whatever you name it, you can create that infrastructure with the help of cloud services. But still you have to maintain it. Whereas with the platform as a service, you do not need to manage the underlying infrastructure, usually the hardware and the operating system, and that will allow you to focus on the deployment and management of your application. So what you do, How the infrastructure is managed is not your concern. You focus on the what part. What? What is more important than how? You must know what is to be done, what is needed, and the how part, that is how things are getting done in the background, you leave it on platform as a service. Okay? Software as a service. And that is the ultimate. So you can understand that this service is cost-wise, it is more affordable. This is a bit costly, and this is the most costly part of the service that if you go for it. But many companies are finding this is much more easier than to invest so many cost. I mean, there will be a lot of cost otherwise. So this ultimately proves to be beneficial or profitable for organizations. They want to save a huge amount of money, so they can go for software as a service. Why? Because software as a service provider provides you with a completed product that is run and managed by the service provider. You do not need to do anything. In most cases, people referring to software as a service are referring to end user applications. Yeah. With SaaS offering, you do not have to think about how the service is maintained or how the underlying infrastructure is managed. You only need to think about how you will use that particular piece of software. So basically, you think of the end product and how it is going to be distributed and getting available with your clients. So a common example of SaaS application is web-based email, where you can send and receive email without having to manage the features. So you do not need to know what is happening in the background, how a mail goes from one party to the other party. Okay, you do the application part of it. That's all. As I said, these are all taken from the cloud, I mean AWS. So these are from the AWS documentation. Okay, you can go through this. The same infrastructure, the same details for IaaS, PaaS, and SaaS. Now, if you go through this, you will understand the basic differences. Let's say here you are not using any cloud services. You are as if the old customers who had their own data centers or their own setup of the on-premises, the network, the storage, the servers, the virtualizations, OS, middleware, runtime, data, applications, everything. You are the owner. You manage. You paid for all these services, or rather you have built up your data center with all this hardware and software. You basically manage them on premise. It's a huge amount of investment needed. Okay, now your company has decided that you will go over to the infrastructure as a service. You are really not being able to manage everything on your own. You are able to manage, but then you are managing at the cost of a huge expense, because the human part of it is quite costly. Okay, so what you do, you say that the blue ones are the things I will manage, the company will manage. Like what? The operating system, the middleware, the runtime, the data, and the applications. See, data is one thing that the company does not want to give it to the service provider, because data is the most sensitive part. The company can be legally penalized for any leakage of data. So data is the last thing that the company wants to be maintained by a third party or from the service providers. So they think that I will manage this, and okay. So if that is so, then we go for infrastructure as a service. So what is that? We give it to some other vendor, or rather service provider, the cloud service provider, for networking, storage, servers, and virtualization. This will be done by if we take the AWS services for this. That's okay. Now we come to platform as a service. So what we do is we only keep the blue part, applications and data with us, we will manage this application, our data. I will not give it to the service provider. But the rest, the networking, storage, servers, virtualization, OS, middleware, runtime, all this will now be managed by the service provider, the cloud service provider. It's a one-way traffic. So, are you understanding? If I can get a yes or no, something like that, some response. I know it's not a very interesting topic, but it's a very important topic.
Yes.
Okay, great, thank you. So, software as a service. Now you decided that enough is enough. I am not being able to manage the data, and even if I do, there is still leakage. I am not being able to securely keep my data with me. So what's the use? I'm paying a huge amount of money, but still I'm not being able to secure my data. It is still somehow getting hacked, somehow getting leaked, somehow my applications are performing not well. They are day by day, the performance has degraded. So what I decide, finally the company has given up, said that okay, my customers are not very happy. So what you do, AWS, Amazon, please take the entire thing from me and you manage everything. I will pay you. But also this payment, all these charges are quite less than if you think of this one or this one. Maybe they are definitely going to pay a bit more than platform as a service, definitely, because now the applications or data is also responsibility of the cloud provider. So entire these gray areas are actually your gray areas, right? Or your company's gray areas, which they were not being able to manage or maintain. So the entire thing comes. This is only possible. I will not go for any other cloud. I will go for a cloud which can definitely is a renowned one who has proven track record to manage everything like this. So I can easily go for AWS. Clear? EC2, a virtual server in AWS. You can create your EC2 is the basic fundamental. EC2 is the Elastic Cloud Compute Cloud, or you can say Elastic Cloud Compute, whatever it is. EC2 is the basic fundamental block around which the AWS is structured. You will create your own server, and that server is, if it is on the Amazon cloud, it will be called Elastic Cloud Computing, CC. EC2 provides remote operations of virtual machines on Amazon's infrastructure. A single VM is called an instance. Virtual machine. This is all whatever you do on the cloud is virtual. So that is an instance. And there are different instance types that differ in their available resources. So you can create a big instance, you can create a medium sized instance, or a low or a micro instance. A micro instance is the only EC2 instance that is free. There is a free tier concept. That means for 12 months, after you have created your account on AWS, your account is on a free tier. So one of the instance, not a big one, but yes, it is good for your learning. You can start working on AWS by creating a micro instance, and that is absolutely free. That is one of the important features of AWS. You know, it will give you many things for free for the first 12 months. Okay. Sorry. Amazon machine images. Now everything is an image, you know. Sorry. You package your application, a big application like you have developed it on Java or Python or PHP or whatever you mention. It's a big software, okay, that you have developed. But then how will you deploy it? It is not early days. Earlier days, you have to take a lot of deployment strategy. It will take you months to deploy, or maybe a month to deploy a very complicated application. And nowadays, what you do, within minutes you deploy. Amazon itself, that e-commerce site, you know how many deployments they do over a day. Basically, every 16 minutes they can do one deployment, a very complex deployment. They don't need much time, not even a day, because they can package their entire service or application into an image. And that is what we have to learn in DevOps, the containerization. With a containerization technology, like with Docker and Kubernetes, you can very well deploy the your applications over an image. Okay. So now that is, you will say that, okay, I have provisioned my EC2 instance. How will I create an operating system? How will I, if you buy a laptop and if you do not get an operating system, will you be able to operate that laptop? Never. Laptop is just a hardware piece. It's your laptop, okay, but it cannot. It's a dumb box otherwise. But you need to have an operating system. An operating system. Now you have to. The vendor can install the operating system, or you can install the operating system like Mac or Windows. It may take you days, but finally you will be successful. But here, within few minutes, you just get an image of the operating system. It can be a big operating system like Red Hat Linux or Ubuntu Linux or Amazon Linux or SUSE, or you name it, Fedora, CentOS. These are big OS operating system in the Linux in the Linux world. Linux is, you have to have a knowledge of Linux, otherwise you will not be able to survive in the IT industry. And especially if you want to be a DevOps engineer, you must go for understanding of Linux. And this machine image, AMI, Amazon machine image of Linux, will be just attached to it. That is the technology, the beauty of it. You do not need to install it. It will be attached to your instance while the instance is getting created. So an instance will be created, EC2 instance will be created along with the machine image of the operating system. Okay. So those that comes as a package or as an image, bundle as an image. The entire software will come bundled as an image, and you will deploy your application as an image, everything. That is why we need to know this automation and how do you do it, orchestration, how do you do it with Docker and Kubernetes. As we said, Elastic Block Store is another, it's a part of the storage, you know. We were just going, if you had a look at that particular thing, that it is part of that storage service, Elastic Block Store. It's a block level storage. It's a sort of a volume. EBS volumes are network attached and persist independently from the life of an instance. Okay. So this EBS volume will be attached. Again, this is like an object. It is like an object. Everything is an object, a service over on the cloud. You can attach this EBS volume of whatever size. Maybe it's a 8 GB or 20 GB or 100 GB. You attach it to your EC2 instance. Once you do that, your size of the storage is determined while you create your EC2 instance. Okay, it can the storage volume can range from 1 GB to 1 terabyte, 1 gigabyte to 1 terabyte. So in one attachment, you can attach 1 terabyte of storage to your server. And also, this is a snapshot. I think you understand what is a snapshot. EBS provides the ability to backup point-in-time snapshots of your data to S3. Now, S3, as I said, is a simple storage service. Now, that is a storage service provided by Amazon, and the instance can go, can crash, though there is almost a zero possibility of that, because Amazon is managing your EC2 instance, so there is no question of it. But still, you may need a backup point in snapshot. This snapshot, that means some application you have deployed on your EC2 instance, but before deploying that application, you might think that this application might not go correctly. So I need to have a backup point. That means whatever was running before installing this application can be restored. I can roll it back to the previous point if the current installation or current system does not work. It's a very, very important, so that the image of that point in time, whatever was there with that EC2 instance, how it was running, that journaling will be stored into your S3. Suppose something has gone wrong, so your server is not booting up because of the new application that's gone in. So what you do, you retrieve your EC2 instance at that point where you have taken that snapshot. So you will retrieve that snapshot and your system is back again. You are saved of a big misery. Otherwise, you could have been sacked. These are very serious, goof ups, if I am allowed to mention that word. That means you need to be responsible of the data of the system, and if you do not do something which can retrieve, something can go wrong. See, IT industry is always a possibility of something going wrong anywhere, anytime, isn't it? So this EBS will give you a provision of the snapshots. You can take incremental backups. Okay, this is a very beautiful feature.
Live video.
Simple storage service, as we have just told you, this is one of the most popular services available with Amazon. S3 is a minimalistic data hosting service. Storing data and downloading data in S3 are built separately. Okay, that billing is different thing as you use the S3, but S3 is a safe and secure place over the cloud provided by AWS. So where you can store your source code, your data, important data, your images, your whatever you say. And at any point of time, you can retrieve those photos, those images, those source data. So many application houses use S3 as their storage service. Elastic load balancer. Okay, so I will just go a bit faster. So I thought I would make a diagram of it, but it's okay. You will understand. Let's say you have created lots of instances. There are, say, 5 instances. 5 instances means EC2 instances, servers. Your application is distributed over the 5 instances, servers. And it is not necessary that those servers are only in a particular region, in a particular availability zone. And within that region also, there can be distributed over the several availability zones to spread away the load, spread out the load evenly. Now, and this can happen cross region, this distribution of the load. Now, what happens when there is a huge traffic coming in for accessing your application distributed over the availability zones? Can it, you do not know, you are the end users, you are coming from outside. How will you know which particular instance at that point of time is having lesser amount of load, such that your query is diverted to that particular machine or that particular virtual machine or instance? You do not know. You have no way to know that. So why don't we do one thing? We install an elastic load balancer, which is also maybe a server or an instance, but a service installed over there which is called elastic load balancer. So elastically, that so all the requests will come and hit the elastic load balancer. And elastic load balancer will have an algorithm. It can find out which of the various available EC2 instances will be available or having a lesser load at that point of time. Are you getting me? So it will divert the traffic to that particular instance where the load is quite less or manageable. So out of 5 instances that you have running the same application, one of the servers is having a bit lesser load than the other 4 servers. So what it will do? It will direct that particular traffic over to that particular instance. And that is the beauty of this elastic load balancer. We will, in our main course of AWS Cloud, we will understand this in a bit more details and with a practical demonstration of how this load gets balanced and distributed over the various instances. As I said, this is elastic load balancer, the details of it. Okay, ELB, the elastic load balancer uses case. And elastic load balancer can take incoming EKS data. This is a Kubernetes, elastic Kubernetes data. So that is a Kubernetes. We will not know at this moment what is Kubernetes, but let's say that is a huge traffic coming from some cluster of network. Okay, so to access your application. So what will the elastic load balancer will pick up this incoming request and route it to one of the several listener instances who can process the data or submit it to the database. So it will pick up that particular listener where it can do it. So this is one use case. If one instance is receiving too much of traffic, the ELB will try to, this is the activity that the ELB is going to do to take the request from the EKS data, okay, and get the data processed into one of the database. But then how? What it does, if one instance is receiving too much of traffic, the ELB will try to route the traffic elsewhere first. It knows there is an algorithm. It can monitor the traffic and the load of each of these instances in its network, whichever it has been configured for. It has been configured for all these instances, so it can monitor the health of each and every instance, and it can decide which server it will have to divert the traffic to. Without the elastic load balancer, one would need a dedicated delegated instance to achieve similar results, and this is much more costlier than implementing ELB, because you have to have a dedicated delegator. So for each instance you will have a dedicated delegator, and that is not a feasible solution. So you need to have an elastic load balancer, and elastic means it can keep on scaling up and down. Without any load balancing at all, you would need to manually and automatically distribute users, EKS data submitters amongst listeners. So you have to do it manually. How will you do it? Or you have to write some scripts and those are not very simple things to do. So why don't you go for an easier path? Take a service from ECS, AWS, go for a load balancer. Just implement a load balancer into your application. DynamoDB. This is a database service that is you can go for it. That means this is a NoSQL database, fully managed. You do not have to do anything much than you give it everything on the DynamoDB. You just have to configure a bit on the DynamoDB, that service. The rest will be taken care by it's a managed service. That's why it is called a managed service. The ability to scale to extremely large data sets while maintaining predictable performance. So it is automatically managing a large database while the performance does not degrade. You have to go for a service provided by AWS. If you have to do it manually or do it through scripts and database application, it can cost you a lot, and maybe you are not getting the desired performance. So why don't you give it to the champion who can do it automatically for you? And there can be a relational database service, like RDBMS like Oracle, Sybase, Ingress. There are so many, MySQL, Microsoft SQL Server, so many RDS available in the market. But you have to hire a database administrator. You have to have developers who can develop on databases, have quite good knowledge on databases. Those are costly inputs. So instead, you go for a service provided by Amazon, AWS, where all these features are completely there for you to for AWS to manage. You just set it up. That's all. And in our course also, we demonstrate how easy it is to just set up RDS on AWS, and you will start instantly running with that technology. You do not have to have much of a knowledge, and that's why these DevOps guys have a knowledge of everything, but maybe not in depth. But they can talk, they can do, they can demonstrate to the developers, to the operations guy, to the testing team what is what. They can assume a role of a mentor. Amazon VPC, Amazon VPC. So what is that? It is the virtual private cloud. Without a virtual private cloud, you will not be able to use the infrastructure as a service, or a platform as a service, or a software as a service. So this is the integral part of your resource. This is the network resource that you must have to implement the cloud or to get the services of a cloud. Virtual private cloud gives you full control over your virtual networking environment. Everything is virtual, but yes, though it's virtual, your work is done virtually everywhere, but your real work is done. You must have in your region at least one VPC. This will include resource placement, connectivity, security. All these things will be done automatically by the VPC. You just have to install it or implement it or use it. You do not need to maybe create one VPC. You can take up a default VPC which is available in your region. That's all. As simple as that. Get started by setting up your VPC in the AWS Service Console. Next, add resources, that is Amazon Elastic Cloud Compute, so you can create your servers on the cloud. You can create your relational database service, that is RDS instances. Finally, define how your VPC communicate with each other across accounts, availability zones, AWS regions. So this VPC is the backbone of your network. Network between the regions or inside the regions, between the subnets. You see, a region will have VPC, of course, one default VPC. This is the virtual private cloud within one region. Okay. You can have You can create one more or two more VPCs according to your custom need in that region. But at least one will be there. Otherwise, you cannot work on this region. And then again, the region will be divided into availability zone. So that availability zone will be based on the VPC subnet. So this is one availability zone. And in this availability zone, there are two instances. Let's say the zone name is AZ1. And there is another subnet called AZ2 availability zone. So in this, there are two instances. In this, there are two instances. How many instances total in this region? There are 4. In the same VPC, there are 4 EC2 instances, but they are distributed in the 2 availability zone. Similarly, in region 2, there is one more VPC, default VPC, and there will be 1, 2, this thing. So in between, you see there is an arrow key. So they can talk to each other over the same VPC. Or if you want to talk to different region, there is also a cross VPC. VPCs can communicate with each other across accounts, across availability zones, so between the availability zones, and also between the regions. These two regions, region 1 and region 2, can communicate with each other because you have a VPC communicate. Okay. Now, Elastic Beanstalk, as I told you, Elastic Beanstalk overview, where you have a Java application. Your developers, you have paid the developers to develop a web application over the web, some application code with some environment configuration. You upload that entire thing with the Java application over onto the Elastic Beanstalk. That's all. Then this is the part that you have to do. That's all. Everything rest of it will be automatically done by the Elastic Beanstalk. So this is a very, very important feature of for the deployment feature of automatic deployment. What it is doing? Deploy and scale the web application. So once you put that into the, you have to configure this. Just from your part as a DevOps engineer or a cloud engineer, you will just need to configure this Elastic Beanstalk onto the AWS Cloud. And once that is set up, you put in any application over here, you want to deploy it. So underlying infrastructure, whether it will need how many EC2s, whether it will need an Elastic, so if you need only one EC2 based on the application complexity and the magnitude of that application, it will decide how many EC2s it will create. EC2 means the instances, the server. If there are multiple instances for the same application to be hosted on multiple instances, then you need an Elastic load balancer. All these things will be automatically done by the Elastic Beanstalk as you have configured. And then it will decide whether to add the auto scaling feature into your application. So, and these are all dynamic, these are all dynamic as the load goes on. So there will be an auto scaling as the load of the traffic goes on. There will be an auto scaling, and the auto scaling will scale up your EC2. That means from 1, maybe it will go for 2 instances. And once there are 2 instances, it will implement the load balancer. So see, this is all dynamic in nature. Who is taking that decision? That Elastic Beanstalk is taking that decision. So down the line, say if you have deployed an application today, can you not expect that if your application is quite popular, so today there are maybe 5,000 users when you started. 1 year down the line, that number of users can go up to scale up to 1 million. So at that point, when it was 5,000 users, it was sufficient to have one instance. There was no need for Elastic Load Balancer. This will decide on that. You can configure that on this. This Java application is not doing anything. Now, once 1 year later, when the number of users or the traffic has gone huge, 1 million users, it can scale it up to 3 or 4 instances. Immediately, it will install a load balancer, which will have the distribution technology, or it knows where to put in the traffic in whichever instance where it is having a less load, and automatically the auto scaling feature will be pressed into operation, because what was 1 year back is not the same scenario. So all these things, why Elastic Beanstalk? Elastic Beanstalk is a service for deploying and scaling web applications and services. Upload your code and Elastic Beanstalk automatically handles the deployment. You see, one of the biggest nightmare is to how to deploy it. Whether you will have a cluster of servers, or you need a cluster of network, all these things will be decided automatically. For capacity provisioning, load balancing, and auto scaling to application, also the Beanstalk will also have one responsibility to monitor the application. So many in one. So many services are there over in Elastic Beanstalk. That is the beauty. Okay. It can also provision S3 buckets depending on what is to be auto scaled. Amazon CloudWatch, as I said, it is used for monitoring purpose, health monitoring. It will use CloudFormation to create the Amazon EC2 instances automatically. CloudFormation, as I said, you can create your Amazon S3. You can create so basically you are coding the infrastructure through some template, and you do not, when I mean to say coding, it does not mean that you have to write a Java code or a Python code. Nothing. Very, very simple. That's why many people are shifting over to cloud. Okay, you code the infrastructure through a template, and that template is given by AWS. So everything is provided by them. It will interactively ask you to configure it the right way. That's all. So you have created a code to infrastructure to code your infrastructure. You can code your infrastructure with the CloudFormation to create an S3 bucket, and you can create your EC2 instances without any sort of a big know-how. That is the advantage. So AWS CloudFormation lets you model, provision, and manage AWS and third-party resources by treating infrastructure as a code. You code it through the template. And as I have told you, this is a very, very important functionality called IAM, Identity and Access Management. With AWS Identity and Access Management, you can specify who or what can access services and resources in AWS. I'm not sure, are you being able to hear my voice and see me and see the screen? Because I have not inquired with you.
Yes. Yes.
Okay, thank you. Because I'm not being able to see you, whether you are there or whether you are being able to see, interact, all the stuff. So do not hesitate to ask any questions. We are towards the end of the presentation. So just have some patience with me and tolerate me for some more time. Okay. So you see, I am a user. I'm an administrator over the cloud, AWS Cloud. I will not allow anyone and everyone to use my important resources and the very, very critical resources over the cloud, because my organization depends, my organization's profit, my organization's revenue, the processes will depend on the performance of those resources, accessibility, and scalability of those resources. So I should not allow anyone who does not have a requisite knowledge to be able to tamper with my resources. So what I will do as a administrator, I will provide an identity and access management utility or service. I will give a fine-grained permissions to it. So why fine-grained? Because there are so many policies, so many privileges and combinations and permutations of those privileges. You can combine this and that. So a person from accounts who is using my AWS resources should not go and tamper with my network, isn't it? Because he has nothing to do with the networking resources. So I will only give a fine-grained permission to that user who is only meant to do the, see, he's from the accounts. He would like to know only the billing. He needs to access only the billing portion of the, because he is more concerned with how much this month the bill has come and what are the resources and what are the justifications. And he is an expert to understand that bill provided by Amazon. So why should I give that user unnecessary permissions and policy to access other resources? He doesn't have any purpose, any job with them. Okay? Did I make any sense? So that's why you have to apply it. So workforce users and workloads with IAM. So who are those? Who can access what? This is what is determined by IAM, identity and access management. So that user can access permissions with IAM policy. So I will give IAM policy permission with that user. So with that, with the help of those policies and permissions, the user can access the resources within our AWS organization. Like if I say what is getting built as a policy, you are saying that you as a user, as an IAM user, I'm a developer, okay, and I need an access to the Lambda function. Lambda function is a distributed function. So it's a very sophisticated function. So as a developer, I would need an access to this resource. I should be able to create a Lambda function. So what I'm doing as an administrator, I'm giving a statement. I'm creating a statement and saying that what is the operation, the service ID. Service ID is to create a function. What is the effect? I am giving this effect to allow this user to create a function. So this is a part of the policy. I'm creating a policy. If I have not created a policy or a permission policy for this user, whenever the user is trying to create a Lambda function, it will get an error, access denied. Lambda create function determined? No. This user, though it's a developer, so the developer will come up with to the administrator and say, sir, I am getting an access denied error. I am not being able to create a Lambda function. So what the administrator will do, will give a fine-grained policy to this user saying that allow create function utility for the action to create a Lambda function. You see, Lambda create function. This is the JSON type of data. JSON. JSON means JavaScript object notation. I'm not going to the details, but you see, this is the key and this is the value. Key colon value pair. So I'm giving a JSON type of policy data and I'm allowing the create function utility for Lambda. So the action is to Lambda, and that Lambda creation can be applied on all the resources. You see, I have given resource star. Star means all. So this Lambda function, to create a Lambda function on any of the resources, is allowed for this particular user. Once this has been applied onto that user, that IAM user will now be able to create a Lambda function on any resource, and therefore this error will not be happening. Is that clear? I thought maybe I should be able to give you a hands-on on how I create an EC2 instance. I have listed down the steps. So in our main course, we will, of course, we will know how to do, and there are lots of many things. But today there is not enough time to actually give you a hands-on demonstration on how to create an instance over the cloud and how to get it connected from your laptop, from Windows or Mac laptop. Okay, but yes, I can just go through the steps a bit without actually demonstrating it. Like, you have to log into your Amazon console as an IAM user, as any user who has resources, access to the resources. Okay, we must select an AWS region on which I would like to create. Like in my diagrams and in a discussion earlier, you have seen definitely a server can be created in a region in a particular availability zone, in a particular subnet. Invoke AWS EC2 compute service. Now, this is one wizard. So we can select a launch instance wizard. So there is a wizard in the AWS console through which I can create my EC2 instance. That is some wizard which will guide me through to the installation process. Select the various elements for creation of EC2 instance. Like I will have to select the AMI. What is AMI? Amazon Machine Image. What is that? That is the operating system. I will select a Linux operating system for operating on my EC2 instance. I need a key pair for authentication. There is no password authentication. When you log into a server, and right now you may be logging into some servers, some application that you might be using, and they might ask you the username and the password. But when you go to a cloud instance like EC2 instance of AWS, you cannot log in with a password. You can log in, but that is not safe. Password is not at all safe anymore. Anybody can hack your password. So you go by the fingerprint authentication. Fingerprint. Your fingerprint cannot be matched with any other fingerprint anywhere of the any. So there are so many billions and billions of human being on the earth. No two human being will have the same key pair or the fingerprint. You will have the security group, which is like you will try not to allow any traffic without the rule set. So it's sudden security that you are implementing with that EC2 instance. You are attaching some volume like 8 GB or 20 GB of storage space. Instance type, that means you are defining what type of instance it is. It is whether it's a big instance or a small instance or a micro instance. Okay, what is the VPC that you select? So you must select the VPC. You may create a VPC of your own, or you can go for a default VPC of that region. There must be one default VPC for that region. And also you can either create the subnets, or better, if you can select a default subnet to start with. I do not need to go into the complexity, make my life simpler by selecting all this already ready-made for you. These are already available for that region. So select that, because an instance will be created on a particular subnet, on a particular availability zone of that region. Region is by VPC, and subnets will denote the availability zone. You review and submit. That means whatever you see, whatever you finally have a review, and then submit. You will create a session. So the instance will be created. That AWS EC2 instance will be created. Now, if you are using Windows, you will use PuTTY to connect to that instance. If you are using Mac OS, you will use terminal to connect your to your EC2 instance. That way, you have to convert the PEM file. We will discuss that in details when we do the main course. It's a very, very interesting subject. You cannot say avoid it. So that is all for today. I think, I hope, and I assume that it was fantastic. I mean, your understanding, at least whatever little you had, this is a bit more, and it will grow more and more and more as you stay along with us. Okay, thank you very much.
Uh, thank, thank you, Mr. Devashish. So now, if anyone have any question, please feel free to ask.
Yes, you will get all the slides. So all the slides, recording, everything. I'm sure, like if you have attended the first one, you are going to get the same thing. You are going to get the slides everything will be available on the website. You get the recording as well.
But to get those slides and all the course content, you just need to do the registration, and it is
Yeah.
free. Don't need to worry. You just need to complete your registration, and you then you will have the access of this class, and you inside the course content you will have those videos from day one and today's video. Along with that, all of the course content and some of the QA as well, quizzes.
Yeah. The quizzes are quite interesting. You can go through them. There is some time limit within which you have to complete. Just you can give it a try. But one thing is that I will not speak anymore. Please let me know if you have any questions directly.
You can unmute and you can speak if
Yeah.
you have any question.
It might not necessarily be the technical ones. You can have any questions regarding the codes and everything. That is also fine.
Then I think we are good to wrap up this.
Can I have a question, please?
Yeah.
Hello?
Yeah, please go ahead.
Oh, thank you. Okay, so are you available on the chat if we have any problem when we are doing our hands-on?
Surely, why not?
You
Okay,
can
thank
you
you.
can
Chat means the
WhatsApp group.
WhatsApp group. Yes. Yeah, sure.
Okay.
Please. I will be more than happy. Do we have any private study? I mean that, Menon, if you can
Yeah.
address that
So
question.
this is our free awareness classes or internship program, but we do have our private session as well. Not private like we do have a batch session, and the next our Devops Cloud Linux session, evening session, CST evening, which is going to start from March end. You can enroll, and that is a 45 days class, daily 2 hours, 5 Monday to Friday, more or less 75 hours. Correction, daily 2.5 hours.
Yeah, that is a more detailed one. This is a 2-hour session, only just having an overview, hand holding with you, so that you get an awareness of what is what, so that when we actually start, you are already ahead. I mean, you already had a head start.
So yeah, study material. If you're asking about the study material, that is already published in our website. I will share the link. Yes, job assistance program is not part of this internship program, because job to assist you on your job hunting, you really need to be a master on DevOps, and for that, this 2 hours weekend class is not good enough. This class is main agenda to give a awareness, like a new one or new IT person, and they are always have some doubt which domain would be good for their future endeavor. Now we plan we'll create some in this kind of stuff, this kind of free session by which newcomers, new IT people, or students, they will have an idea what kind of job they can expect after, if they choose this kind of domain. Now we are going to right now we are have this DevOps AWS one internship program. Soon, I think within this March, we are going to start our cybersecurity one. Then we are going to start business analyst internship program and data engineering one. So, if you have any doubts that what kind of day-to-day activities you will find after joining a particular job role, so this awareness program will help you. It will help you also in other point of view, that it will give you a holistic overview about all the tool set and technologies associated with that particular domain or job. But to be a particularly hands-on expert of that particular domain, this internship program is not good enough, because we do have very limited time uh, to communicate with you, or this class time limit is very less. You just compare, our DevOps classes is 75 hours actual classes, and that is a 45 days daily, 2.5 hours. Apart from that, it consists of another 60 hours hands-on practice. So it is lots and lots of uh, information, as well as practice session, as well as troubleshooting. So there are many things, and through all those drills, then only you can be a hands-on expert, right?
If you are serious and if you want to really be a DevOps engineer, it is this market is 10 years old, almost 10 years old, isn't it, DevOps? So now you want to get into a DevOps job, you need to be very well groomed into this domain. It is not simple. It needs a rigorous sort of your motivation to keep on with it. And we are there, of course. We with our expertise, we will definitely help you, guide. And we have been successful, as we have discussed earlier in our earlier session. We have been very, very successful with so many people coming from non-IT background. So that is also okay. But one thing is that you need to be committing yourself to this if you are decided that you need to be going to DevOps. And see, the development field is so saturated. You can try for a development job as well, but this day by day, this field is getting saturated and more. So you have to be an expert, quite experienced and quite expert to be getting into a development job. So one avenue that is open for you is to get into a DevOps, because that is still a very sort of a good area, not at all saturated. There is a huge demand as well as, and also you can back it up with further knowledge on Kubernetes, further knowledge on cybersecurity, DevSecOps. So all these things are going to happen, because if you are a knowledgeable guy on DevOps, at the same time you have a good knowledge on DevSecOps, which is a security portion, and cybersecurity, that is a separate course that we have. Then people will run after you for getting you as a person working in that company. And you don't worry about the materials, the recording, and you will be, over flooded with all the documents and so many notes that we have. But that is on the main course that we have.
Okay, then I think no one has any other question.
Yeah.
So thank you all.
So
For
shall I stop the recording?
Yeah, please. So thank you all for joining with us, and feel free to contact our WhatsApp group if you have any doubt, any question, and if you stuck anywhere during your lab or practice session, ping over in the group. Okay, then we are. Thank you, Bhagasri.
Thank you all. Thanks a lot.
Thank you, sirs.
Thank you.
Thank you.
Thank you. Thank you.